Chyp is a manufacturing company and they produce electronic devices. And among the models they produce, they have amplifiers. And they are going to launch a new product, a new amplifier, and they need to redesign an existing line so that they can make the best of the existing line. To be more specific, they have a production line which currently has 4 stations, which are depicted here, station 1 to 4, and as we will see later on, we have amplifiers that undergo a process. Several operations are performed here. After that, some other operations are performed here. You're assembling different components until at the very end you have an amplifier, an actual amplifier, which you can ship to your customer and eventually get it sold. Um, and there are precedents among tasks. So those tasks that you have to perform along the different stations should meet some requirements in terms of precedences, as you will understand in a minute when we will see the list of the 12 operations that allow us to allow Chyp to get an amplifier. First, you have to prepare the box, then you have to prepare or assemble the printed circuit board with power module, and then with the preamplifier, and so on. Okay, and for each task we have a duration. Okay, we have some tasks which are kind of long. I'll just need the connections takes 11 minutes, whereas you have others that pretty much take 1/4 of that time, like putting on the cover. But this column here indicates the precedences I was mentioning before. So for you to perform this task, you have to prepare the box first. That's why for you to perform task 2, you had first to have done task 1, and so on. So for example, if you want to heat sink of the push-pull, which will take you just 2 minutes, you should have done first both 4, 5, and 8, those 3 tasks. If not, you cannot do that. Okay, so that has implications in the solution you have to obtain, because the problem consists, I'm going back to our previous slide, is deciding all 12 tasks, which ones you do at station 1, which ones you do at station 2, and the same for stations 3 and 4. And the point is to have a balanced assignment so that this goes as smoothly as possible and you produce as much as possible. You don't want people in station 1 being busy all the time, and station 1 having just one task, which like the one that took 2 minutes, and being idle pretty much most of the time. So ideally you would like to have people working here having the same time for assembling the components that are assembled in station 1 to be working the same time per item, per amplifier, that the guys that are here, and so on, because that way you would making the best use of your capacity. This is a way of representing precedences by means of a graph, but it is exactly the same that we had in this column here. Okay, we have within the circle we have the identifier of the task. On top of it in orange we have the duration, and each arrow represents a precedence relationship. Okay, so for example 5 and 8 are not directly related, but 8 and 6 and 5 and 2 are, and 2 and 6 are. So you need to make sure that these pairs of tasks that are related with precedences are assigned to stations correctly. Let's see an example. We, for example, might assign tasks to stations are as given here, and this is okay. Okay, we are not violating any precedence constraints, so you can make sure that 1 to 3 are all of them prior to 6 and 7. Okay, and you can do the same with the rest, and that is okay. But if you suggested an assignment like this, that would not be a good solution. Okay, because you've scheduled 6 before 3. Okay, and that is wrong, because that might mean that you are connecting the PCBs prior to installing one of them. So that is something that wouldn't allow you to obtain an actual amplifier, and that's why that is not a good option.